Hello friends, welcome to session 2 on projection of lines. Now I'll revise uh, whatever I've done in the previous session and continue with the other problems. Okay, so here this I was telling you, recollect whatever I've done because since this is very important from the understanding any of the complex problems point of view. uh, I need to do this again. Okay. To understand any problems in lines, this is the basics. Okay. Now, the problem is this. One end of a line is 20 mm above HP and the line is 40 mm in front of VP. Line is parallel to VP. Okay. Parallel to VP, inclined at 30 degrees to HP, measures 60 mm. This problem we have done. Okay. This is P dash Q dash is the front view. PQ is the top view. Correct? No. Now, what I'm telling you is significance of the locus in the front view. What you have to know here is the two observations you can make here. One observation is, please understand, two observations we are making here under significance of locus. Okay. One observation is, see here, I'll fix P. That means this P and the P, no, P dash P, this point P, I'll fix and I'll start rotating Q. I'll start rotating the end Q either this way or this way. Going this way is going towards VP. Coming this way is coming towards the observer because observer is here. Okay. But what you should know here is as long as inclination is kept constant and if you start rotating the line with P as fixed and if you're rotating at Q, if you start moving Q, fixing at P, as long as inclination is kept constant, the distance of end Q above HP remains same. Now, this is the distance of end Q above HP, correct? This is the distance of end Q above HP. Even let us say, keeping P fixed, keeping inclination also fixed, inclination at HP is fixed. Let us say, I'll move Q to this random position Q1. Even if I move this Q to random position Q1, inclination to HP is same 30 degree only. Now we have developed inclination to VP. But even in this case, the height of Q1 above HP remains same. That means this Q1 should lie on this locus only. That is the understanding. Okay. That is the significance of the locus in the front view. Okay. In the same way, let us say, instead of rotating this way, keeping this that is P fixed, if I move this Q with a constant inclination of 30 degrees to HP, if I move this way also, okay, as long as inclination to HP is constant, that is 30 degree constant, if you move this way also, the height of Q2 above HP should remain same. Okay, that means Q2 also will be lying on the locus only. That means the distance of Q2 above HP should remain same. At the same time, don't forget, as long as inclination to HP is same, the top view of this line will remain same. See here, this P dash Q dash in the front view, no? This is the top view. As long as inclination is constant, and if you rotate with respect to Q, okay, fixing at P, if you rotate Q, if you rotate the line PQ, fixing at P and moving Q, rotating PQ, okay, when you do this, as long as inclination is kept constant, this length of the top view will remain same. That means PQ will be same as PQ1, some random position. PQ is same as PQ2, some other random position. That means what you should understand is, as long as inclination to HP is constant, and if you rotate the line with respect to Q, okay, fixing at P, if you rotate the line with respect to Q, the length of the top view remains same. Okay, that means with P as center, Q as radius, I can draw an arc this way or I can draw an arc this way. Throughout, this you should understand. When you're drawing an arc this way, okay, in any position here, the inclination to HP is always 30 degree only. Because as long as inclination to HP is constant, the length of the top view remains same. That is why with P as center, PQ as radius, I'll draw an arc. Okay, I'll draw an arc. I'll draw an arc here also. But whatever, if I draw an arc, in the throughout this position, the length of the top view remains same. That's why I'll draw an arc. But let us say this is random position PQ1. In this PQ1 also, inclination to HP is 30 degree only. But now inclination to VP has developed. This we'll find out what exactly is inclination to VP later on. Even in PQ2 also, random position PQ2, okay, which is equal to PQ, inclination to HP is same. That is 30 degree only. But inclination to VP has changed. Okay, initially PQ it was parallel to VP. Now this is inclination to VP, this is inclination to VP. That is why when you draw an arc here, either this way or this way, you should know throughout this arc, the inclination to HP remains same, that is 30 degree. This you should know. That means I'll repeat where the significance of locus in the front view. Okay, as long as inclination to HP remains same, okay, and if you rotate the line with respect to VP, that is keeping P fixed and moving Q, okay. If you rotate the line, the two observations can be made. One is length of the top view remains same. That is why I draw an arc, either this way or this way. That means P as center, PQ as radius, I'll draw an arc. Drawing an arc is the significance of drawing an arc is as long as 30 degree, that is inclination to HP is constant, the length of the top view remains same. That is why I can draw an arc this way or draw an arc this way. Throughout this process of drawing an arc, the inclination to HP is always 30 degree. Then another important observations what you can make is, in the entire process, whatever you do, as long as inclination to HP is constant, the distance of the end Q in any position above HP remains same. That means it should lie on this locus only. Let us say I have rotated this line to one random position PQ1, that red one. Then the corresponding front view of this will be, you push it here, Q1 dash should be on the locus only. Okay, Q1 dash should be on the locus only. Then join P dash Q1 dash and all that. What I'll tell you later on. Let us say I'll rotate it. I'll bring it to PQ2 position, let us say. Well, in this position also, PQ is same as PQ2, you know, because inclination to HP is the same. The length of the top view remains same. That also, that you know. But in this position, PQ2 position, the height of Q2 above HP should remain same. Even in this random position, Q2 above HP remains same. That's why to get Q2 in the front view, what I'll do is I'll take the projector and dash against the locus. That is Q2 dash should be on the locus. This is a very important concept, what you should know. Okay. This I've told you already, I'm telling you again. Okay. Now line AB is inclined at, is here. Now it is another problem, basic problem. There it was inclined to HP, now it is inclined to VP. You see here, line AB, inclined at, this is VP. Okay, this is it. Line AB is inclined at 30 degrees to VP, correct? Huh? 30 degrees to VP and is parallel to HP. The line measures 60 mm and is inclined at 30 degrees to VP and parallel to HP. Okay. Once it is parallel to HP, then you know very well the true length can be seen in the top view and all that. Okay. One end of the line AB is 20 mm in front of VP. Can you follow? 20 mm in front of VP. And the line is how much above HP? 40 mm above HP. Correct? No? The line is 40 mm above HP. That means the line is this way. The line is in the space in front of VP above HP. The line is AB, capital AB. It is in the space inclined at 30 degrees to VP, parallel to HP. And the line is 40 mm above HP. One end of the line is 20 mm in front of VP. For which, when you are looking from the front view, how it appears on VP, when you are looking from the top, how it appears on HP. And also I have told you so many number of times, the direction of vision always is perpendicular to VP for front view, direction of vision perpendicular to HP for the top view. In that way, I want on front view and top view. Front view will be this, A dash, B dash, top view will be AB. Okay. Now, in this position, in this problem, okay, I know very well that top view is this AB and front view is A dash, B dash. A dash, B dash and AB, they have to be written, and they are the front view, top views, and they are the projections. That is, writing projections is called as writing front view, top view. Now you see here. Now you see here. Now XY VPHP. Now you can't start from the front view because front view distance I don't know. Front view distance depends on the inclination to VP. Correct, no? Inclination to VP. More the inclination to VP, lesser will be that distance and all that. Length of the front view. If it is 50 degree, A dash B dash will be much reduced. If it is 70 degree, still more reduced. Okay, in that way, the A dash B dash front view length depends on the inclination. You don't know what exactly A dash B dash, but at least you know AB, no? Because since it is parallel to HP, the true length can be seen in the top view. That is why what I'll do is, one end anyway is 20 mm in front of AP, I'll take 20 mm. Okay, once I take 20 mm, I'll draw AB which is 60 mm inclined at 30 degrees to AP. That is 60 mm. That means since it is parallel to HP, you have to start from the top view. Previous problem it was parallel to VP, you started from front view. Okay. Now it is parallel to HP, you have to start from the top view. Draw the XY line, VP HP, take 20, this 20, get A. From A, draw AB at an inclination of 30 degree, you get the top view. Okay, take the projectors up, and you know very well, A dash B dash is at a distance of 40 mm from XY line. That is 40 mm from XY line, you have A dash B dash, which is the front view of the line. Okay, this is the front view of the line. This is the top view of the line. Okay, now this you don't forget. You are once you look at this problem only, you should be in a position to say these things. See here, this A dash B dash. The distance of A above HP, distance of B above HP, same means immediately you should know that the line is parallel to HP. Okay, this type of thing you should know very well here afterwards how to analyze a problem. If A dash B dash is parallel to XY line, then AB should be parallel to HP. Okay, in the same way, you see here in this problem, if you observe, PQ is parallel to XY line. That means the distance of P and distance of Q in front of VP is same. That means it has to be when the distance of end P and end Q in front of VP remains same, immediately you say the line is parallel to VP. That means whatever you see here is in true length. Okay, I'm telling you again, looking at this front view, top view itself, you should be in a position to understand what exactly is happening in this problem. Now looking at this, you can say, since PQ is parallel to XY line, okay, immediately you say distance of P, distance of Q in front of VP same means P dash Q dash, whatever you have is in true length. Line is in actual length only, no apparent length, true length only. The line is parallel to VP. You can directly say line is parallel to VP. In that way, here you see here the distance of A above HP, A dash above HP, distance of B dash above HP same. That means line is parallel to HP. That means as soon as you see this line parallel to XY line, that is A dash above XY line, B dash above XY line, same distance above XY line. That means if A dash B dash is parallel to XY line, then AB, whatever you see here, that should be in true length. Okay, that means this is in true length. This you can never forget. In case front view is parallel to XY line, the corresponding top view should be in true length. In the same way, if top view is parallel to XY line, the corresponding front view should be in true length. Okay, this you never forget. As you see here, you can clearly say one end of a line is 20 mm in front of VP. Line is inclined at 30 degrees to VP. Line measures 60 mm and the line is 40 mm above HP. Once you do this, yet look at this only, A dash B dash parallel to XY line means line is parallel to HP. That you can clearly say it is true length in top view. This is true length. Okay. This is the end of session 2 on projection of lines. We'll continue in session 3. Thank you very much. Thank you.